Welcome, everyone. My name is Chase Wertsmith. I'm an application engineer at Zoller Company. We appreciate you joining us for our Introduction to Submersible Wastewater Pumps webinar. Before we get started, I just want to cover a few details. Should you have any questions after we wrap up today, you can send them to webinars@zoller.com and we will get back to you. Now that those details are covered, I want to start off by telling you a little bit about myself. Again, my name is Chase Wertsmith. I began my career at Zoller in December of 2022. I graduated from the University of Louisville with a Bachelor of Science in Mechanical Engineering and am an engineer in training, currently gaining experience for my professional engineer license. I currently hold the role of application engineer on the quotations team, assisting with pump sizing, basin sizing, hydraulic analysis for low pressure sewer systems, and other specialty applications. So now that you know a little more about me and my background, let's go ahead and get started. So today I'm going to be primarily talking about submersible wastewater pumps, and this is going to be more of an introduction and maybe a bit of a review for those that do have a little bit of experience with submersible wastewater pumps. So with that, let's go ahead and jump right on in. So why do we use pumps? We all know that water flows downhill due to gravity, but we don't always want water to be at low points. We typically want to remove water from various locations, such as basements or construction sites, or we want to move water to a high point location for storage and then to be used for a later time, such as in water towers. The way that we do that is by using pumps. Pumps allow us to overcome gravity. They allow us to move water from a low elevation to a high elevation. And not just are we able to overcome gravity with pumps, but they also provide certain benefits over other types of systems, specifically gravity. One major system is going to be lower capital costs when compared to gravity systems. Typically with gravity systems, you have to utilize large diameter pipe, usually starting at 6-inch or even 8-inch pipe, and maintain a certain slope with said pipe. Whereas with pump stations, you can typically get away with much smaller diameter pipe, even go down to 2-inch, 1.25-inch sized pipe, which tends to be much cheaper than larger diameters. Also, with pumps, you can simply install the discharge pipe below whatever the frost level is in the area and simply follow the existing grade. So excavation costs can be much lower compared to gravity systems where you have to maintain a certain slope in order to keep your water and sewage moving through that system. So pumps being installed in very hilly or rocky environments, excavation costs tend to be much cheaper in that type of application. Another benefit is flow equalization. What I mean by that is you know how much flow is going to be moving through your system whenever that pump is called to run, as well as the velocities of the water moving through that system. So you know that you're going to keep your solids suspended if you're in a sewage application, and you know how much water is going to be moving through that system, so you can size your treatment facilities specifically around that flow. And then pump stations can be used in all sorts of alternative treatment systems. You can use them in drip systems, which is an on-site treatment system where you need pressure to evenly distribute your water to the surrounding ground area that the system's installed in. Or a low-pressure sewer system where you need pumps in order to overcome pressures caused by other pumps in that system. All these pumps are going to be pumping into one main line, going to your treatment facility. And then there are quite a few other treatment systems that are out there that utilize pumps. These are just to name a few. So now that we've covered why do we use pumps, now we're going to address some additional topics, such as automatic versus non-automatic pumps. We'll talk about different types of wastewater. We'll talk about pump types and the type of applications those pumps are specifically designed for. We'll also cover some key design considerations when you are designing a pump station. And then lastly, we'll go over some installation best practices. So first, let's talk automatic versus non-automatic. An automatic pump is going to have some sort of float switch that is attached to that pump. It's going to have some sort of starting mechanism that's going to come along with that pump. Typically, that pump can be easily dropped in, plugged in, and it's ready to go. There's no additional start components that are required for that pump to operate. Typically, you're going to see automatic pumps used in residential and light commercial systems where you don't necessarily need a lot of control over when that pump turns on and off. Then you have non-automatic pumps. Non-automatic pumps do not come with a attached float switch. You're typically going to need some type of external start component, be it a piggyback float switch or separate float switches with a control panel. Non-automatic pumps are going to typically be used in all sorts of different applications, and they typically fit a wider range of applications as well. So you'll see them in residential and light commercial and even more commercial facilities that need a lot more flow capability. Non-automatic pumps, you typically have much more control over when that pump turns on and off, so you can set your float switches in any configuration that you want in order to ensure that you're pumping the right amount of water out of your system to fit whatever the incoming flows are. So now let's define various types of wastewater. First off, we have sewage. Sewage is going to be anything that is going to be flushed down a toilet or a floor drain or sinks, showers, dishwashers, and typically sewage is going to have some large solids going down these drains, making their way towards the pump station through the home or the facility sewage system. Effluent is going to be water that is still wastewater. It's dirty water, but it's going to be much cleaner than sewage. Typically, effluent is going to be found in septic tanks. You're going to typically have a pump in that septic tank, or you're going to have a separate dosing tank or pump chamber that is detached from that septic tank. And usually inside of the septic tank, you're going to have your wastewater come in, and then all of your solids are going to float to the bottom of the tank, whereas all of your fats, oils, and greases will float to the top of the tank. And in between the two is going to be your effluent, which is what is going to be primarily pumped out of that system. So you're really leaving behind all of those problematic solids and fats and greases and only move the wastewater from that system. And then lastly, you have groundwater. Groundwater is really going to be, just as it sounds, it's going to be water from the ground. You might have storm water as well. And typically you're going to have a pump installed in somebody's basement in the slab, and that's going to be pumping out any water that it would otherwise collect inside of that basement. Now, it's important to note that each form of wastewater is going to utilize different pumps, and we're going to talk about the different types of pumps and where exactly you're going to use those pumps. So the first type of pump that we're going to talk about are sewage pumps, and there's really two main types that we're going to discuss today. The first type is going to be a standard non-clogged sewage pump. These pumps put out very high flow, but don't handle very high heads or high pressures that you might find in a system. And these pumps are required to pass at least 2-inch spherical solids. Now, some of these pumps can be made to pass much larger solids, but in order to be considered a non-clogged sewage pump, they must meet that 2-inch minimum. Typically, you're going to have a space between the impeller and the inlet of that pump to allow those solids in and to prevent any sort of jamming to occur. When it comes to non-clogged sewage pumps, you have to use at minimum 2-inch pipe or larger, and that is just to, again, allow you to pass at least 2-inch spherical solids. Then next up, we have grinder pumps, which is a sort of specialty non-clogged sewage pump. These pumps have a grinding mechanism on the bottom of the pump that is going to grind up any sort of solids. It'll grind up rags or wet wipes or anything that gets flushed down the toilet, but that should probably not be there. These pumps are typically going to grind them up and pass them through your system. They do this through a cutting mechanism on the bottom, and then that inlet there is going to have small holes to allow all of those ground up solids in. These pumps can come in single directional or they can come in reversing. A reversing grinder pump is going to have a symmetrical design. So not only is the pump itself going to be symmetrical, but that grinding mechanism on the bottom will be symmetrical, like that star shape there, as well as the impeller as well. This way, no matter which direction that pump is operating, it's going to get the same performance capability. These pumps can be used with 1.25 or 1.5 pipe, so you can go below that 2-inch minimum that is required for non-clogged sewage pumps. And that's just because since these are ground up solids, you're much less likely to clog that pipe, so you can get away with much smaller pipe. And these pumps are great for high pressure systems, which is why you typically find them in low pressure sewer systems. Now, one thing to note about sewage pumps is that scouring velocities are critical, and that's for both non-clog and grinder pumps. What I mean by scouring velocities is there is a certain velocity that you have to hit in a sewage application in order to keep your solids suspended. So, if you are actually going below whatever your scouring velocity is, you can actually start to have those solids start to settle in that pipe and slowly start to clog that pipe, which will increase the pressures on the pump. Thus, that pump puts out less flow and less velocities, which will start to clog that pipe even faster. So you always want to make sure you are hitting scouring velocities. Now, what is the minimum force main velocity? So on here, on your screen, you're going to see Schedule 40 PVC minimum force main velocities. The minimum scouring velocity that you need to hit is 2 feet per second. And that has been a requirement for a long time now. But in the past 20 years or so, we've seen a lot more solids getting flushed down the drain, solids that really shouldn't be getting flushed down drains, such as wet wipes and rags. And that can actually start to cause clogs in your system, as well as nowadays we have water conservation in mind. So we have low flush toilets, low flow shower heads. So really what's happening is we're getting less water in our sewage basins nowadays with more solids than ever before that really shouldn't be in there. So in order to keep those solids moving with that less water, we recommend you hit at least 3 feet per second minimum in your sewage applications. It's still a requirement to hit at least 2 feet per second, and for the most part, you're usually good, but hitting that 3 feet per second minimum is going to allow you to ensure that your pipes remain scoured and clog-free. So here I actually have a video of a grinder pump grinding up solids. Here we're shoving all kinds of rags and wet wipes inside. This piece here is actually a conglomeration of multiple rags put together, wet wipes put together. And you can see once that pump grabs onto it, it's going to keep on rotating and grinding it up until eventually it turns it all into a slurry and moves it through your system. Now here's something that you typically don't get to see with grinder pumps, and that's the ground up solids on the other side. Here you can see all those rags and wet wipes turned into very fine material. So you see it very easily falls apart, and that would move through your system very easily. So with that, I'm going to move on and explain the difference between radial versus axial cutting. So the original grinder design was a radial cutter, and this radial cutter is going to have a plate or a stationary plate around the outside diameter, and then in the inside diameter is a rotating ring. And this rotating ring is actually going to push all of your solids in between that stationary plate and the ring and grind up that material. Now, the main problem with this type of design is that these ground up solids can actually start to catch in the grooves, which is located around here, and jam up your pump, which is why we utilize an axial cutting mechanism. This axial cutting mechanism has a stationary plate, and then on top of that plate is going to be the cutter. And that cutter is going to provide scissor-like cutting action, and it's much less likely to jam compared to that of a radial cutting mechanism, which is the reason why we use this axial cutter in our grinder pump designs. So when it comes to the installations for sewage pumps, Indoor installations, you're typically going to have very compact poly basins or maybe even compact fiberglass basins, and usually you're going to be using an automatic pump. Now, you can use either a simplex arrangement or a duplex arrangement, simplex being one pump and duplex being two pumps. The simplex arrangement is by far the most common, but if you do want to utilize a duplex arrangement in an indoor application and using automatic pumps, you can actually use what's called an alternator, a residential alternator that will alternate your automatic pumps whenever they're called to run. So that way, only one pump is running at any given time, and thus you get the redundancy of having that second pump in place and that added protection. Now, with an outdoor sewage system, you're typically going to be using either a larger poly basin or a custom designed fiberglass basin. And these basins, again, you can either use a simplex or a duplex arrangement. And usually in most outdoor applications, I would typically recommend rail systems to be used, although you don't necessarily have to use a rail system, but you need some sort of disconnect system inside of that basin in order to be able to pull those pumps. And we'll talk a little bit more about that later on in the webinar. So now let's discuss effluent pumps. So effluent pumps, again, they're primarily going to be pumping liquid wastewater. They should not be handling any sort of solids. These pumps put out high flow but lower heads, just like those non-clogged sewage pumps. And these pumps can be used in step vaults. Typically, you're going to use them in a simplex arrangement in the step vault. A step vault is a sort of housing that's going to be put inside of your septic tank that the pump is going to be inside of. And that step vault is usually going to have some sort of filter to protect that pump from any of the solids that are in that septic tank that may make their way over towards where the pump is located. Now, these pumps are fantastic for pumping to distribution boxes, low pressure pipe, or drain fields, specifically gravity drain fields. They're great for this because of those higher flows, although with the lower head capacities, you're typically not going to use them in systems that require a lot of head pressure. Now, the pump that you would typically use in a higher head application is going to be a turbine effluent pump. These pumps typically put out lower flows, but have higher head capacities when compared to centrifugal pumps. You can typically get these pumps that can handle up to about 400, 500 feet of head, which is much higher than your standard centrifugal. These pumps are going to be quite different from a centrifugal pump. The inlet to the pump is actually going to be in the center of that pump, and it's usually going to have some sort of smaller inlet holes inside of that pump just to help keep any sort of large solids out. The motor is going to be on the bottom of that pump, and then along the top is going to be your impellers, and then up to your discharge. So these pumps contain multiple impeller stages, and that's shown here on the right. You can see all of these different impellers stacked on top of each other, and that's what gives these pumps the high head capacity that you see with them. When you put impellers in series, that's going to allow for a pump to handle much higher heads, but that'll typically lower their flow capacities just a bit. These pumps are very easy to install, especially when paired with a step vault, and you can put these in simplex or duplex step vaults. And then these are best used for high head type applications, such as drip systems, low pressure pipe systems, recirculating media filters, and then you can also use them in effluent force mains, where it's very similar to a low pressure sewer system using grinder pumps, but you instead use effluent pumps and really only be pumping effluent through that system. Now, the thing that is most important when it comes to effluent pumps is that these pumps are non-automatic only. The reason for that is in effluent applications such as septic tanks, you have corrosive gases that will actually eat away at your pump if they are exposed to those gases, and you'll end up with a pump that looks like this. So you can see that the cast iron on this pump has just completely melted away, and this pump is no longer capable of operating like it used to. So in order to prevent that from happening, you must keep that pump submerged at all times in your effluent application. You can't do this with an automatic pump due to that float switch being on the side of the pump. that water level will always go below the top of the pump. Whereas having an automatic pump with your float switches placed above that pump is going to keep that water level above that pump at all times, thus protecting your pump from those corrosive gases. So your typical installation, if you are doing a septic tank with a separate pump tank, looks a lot like this. You're going to have your pump on, this is shown on the right side here in its own separate tank, and you can see the off float. So over here, you can see that that off level is going to be above the top of the pump to prevent that water from ever going below. With this type of installation, if you're hard piping your pump in, you're typically going to want some sort of stand to keep that pump elevated, just to protect that pump from any sort of gritty material that finds its way through the filter. And speaking of filters, you're typically going to want a filter before that pump tank to protect the effluent pump from those solids. Now, when it comes to smaller residential systems, you'll typically use maybe our WW1 effluent filter, which is just going to be one filter, or if you're going to install in a commercial facility, we would recommend using our WW4 filter, which is going to be made up of 4 filters. These 4 filters means that you can go a much longer period of time between cleaning those filters, whereas if you use a single filter in a commercial facility, it's very possible that those filters will end up clogging from all of that sludge and material that makes its way into that septic tank. Now, you also have a 2-compartment installation or just a direct installation into your septic tank. Using a step vault. So here with the step vault, you can see your pump is installed inside that vault with your float switches. And then you also have this filter here that comes with that vault that is going to protect that pump. So you don't need a separate filter in that tank to protect it. Now we're going to recommend a baffle wall to protect your pump and filter from any material coming into that inlet, along with a drop pipe that is going to prevent solids from very easily making their way into that pump chamber. However, you can also install these vaults into single compartment septic tanks. It's just important to maintain that system by performing regular maintenance on your filter, pulling that filter out, and spraying it off in case of any clogs occurring to protect your pump. So now lastly, let's talk about groundwater and stormwater pumps. So usually with groundwater systems and stormwater, you're going to use centrifugals. Typically, you're going to use smaller automatic centrifugals for groundwater systems, maybe in somebody's basement or in a very light commercial application. And these are typically going to be available in pre-engineered drop-in systems. Since most of these types of applications are very similar across the board, you can get away with putting the same install into multiple homes. Now, when it comes to stormwater, you're typically going to use larger non-automatic pumps with more custom designed systems. And that's because stormwater is typically going to be designed around high flow conditions, such as hundreds of gallons per minute in flow. So you're going to need a much larger pump to handle those flows. Now, typically, you can also utilize backup systems in smaller groundwater applications. You're really not going to use these in stormwater systems, but if you're installing these into residential systems, you'll want to use some sort of backup. These backup systems add in redundancy similar to a duplex arrangement with 2 pumps. So if your main pump fails, you still have that backup in place to keep your basement dry while you try to get that pump replaced. Another thing that these backup pumps provide is peace of mind when the power goes out. These pumps are typically going to run on some sort of backup power, be it a DC powered backup with a battery, such as using our Aquanaut 508 Fit, where you're going to have that backup pump that will operate even if your power goes out. Or you can use a water powered backup that's typically going to be hooked up to your incoming water line. And using that water will pump out your system if your pump ends up failing or if power does end up going out. So let's talk a little bit about dewatering sumps and how exactly they're installed. So usually in residential and light commercial systems, again, you're going to have some sort of pre-engineered system that will likely work for that application. Typically, it'll be installed in some sort of poly basin, and you will have typically an automatic pump, although you could get non-automatics for these systems as well. Next up, we have elevator sumps, and this is sort of a specialty application where you're typically going to be installing these at the bottom of some sort of elevator shaft. Now, elevators need oil in order to maintain proper operation, and this oil is usually at the bottom of that elevator. Now, the problem with that is you don't want to pump out your oil. So you need some sort of specialty system to keep your oil in place, but to pump out any water that starts to collect at the bottom of that elevator shaft. The way that you do that is using an oil smart pump switch. And that can be seen here on the right. This oil smart pump switch will actually detect oil using this short probe here. And once it detects water, it will then turn the pump on and pump that water down into the bottom of that longer probe. The reason why this works is that oil floats on top of water. So this way you always know that the oil is staying in your system while your water is being removed. Now let's talk a little bit about interchangeability. And what I mean by that is, can a sewage pump, for example, be used in an effluent application or vice versa? So here I have a chart with the application along the left side here, so sewage, effluent, and dewatering. And then along the top, I have the different types of pumps that we have just talked about. So can you use a sewage non-clog pump and say effluent application? Let's take a look. So for sewage applications, you can use a sewage non-clog pump, or you can use a grinder pump. That's what they are specifically designed for. However, you should not use an effluent pump or a dewatering sump pump in these applications. The main reason for that is effluent pumps and sump pumps are not designed to pass 2-inch solids, so they will very quickly clog, and you will no longer have a pump in operation. So only use grinder pumps and non-clog pumps in sewage applications. Now, in effluent applications, you can get away with using a sewage pump, specifically a non-clogged sewage pump, effluent pumps, or sump pumps in that application. Now, you still need to keep these pumps submerged at all times. But when it comes to grinder pumps, it is not recommended to use a grinder pump. The main reason for that is that cutting mechanism is not being utilized inside of that septic tank. All you're doing is pumping water, and there's nothing that you really need to grind up. And typically, you really don't want to have any sort of solids be passed through your system or ground up through your system into the discharge, because that can very quickly clog any sort of drain field that you have in place. Also, when it comes to grinder pumps, you don't want to pump to a septic tank with a grinder pump. The reason for that is that this ground up sewage, when it goes into that septic tank, it's not going to really separate from that water or from the effluent. And so you're going to end up with clogged filters. You might end up with a clogged pump, or you could end up having the effluent pump pass that ground up solids into your drain field and cause a clog there. So really, it's just never really recommended to utilize a grinder pump in an effluent application. And then lastly, we have dewatering applications. You can use a non-clog pump, you can use an effluent pump, you can use a sump pump. But again, we would not recommend utilizing a grinder pump, mainly just because you're not going to be grinding up anything. Grinder pumps tend to be a little bit more expensive than some other types of pumps. And so you'll really just be paying more money on a pump that's not going to really be doing what it's designed to do. So this is not really a pump sizing course, but I will give you the right questions to ask when you are trying to make a pump selection outside of just what you're pumping. So you need to know what your electrical conditions are in your application. Specifically, are you using 208 volt power? Is there going to be 230 volt power? Will there be single phase or 3-phase power available? Pumps are typically going to be designed and ordered based on this specific electrical condition. So you want to make sure that your pumps are going to fit those electrical conditions, or else you can end up with a burnt up pump or a pump that's not operating correctly. You also want to know whether or not it's a residential, commercial, or municipal system. Typically with residential systems, you can get away with using an automatic pump and using a much smaller enclosure compared to that of commercial and municipal systems. Typically commercial municipal systems, you're going to want a large basin, and they may want some additional bells and whistles in those types of applications that you otherwise wouldn't really use in a residential system. So it's important to pay attention to the type of application you're putting them into, as well as the type of building that pump is going to be servicing. You need to know what is being pumped. Again, we've already really discussed this. Primarily, are you going to be pumping sewage, effluent, or just groundwater? You need to know where exactly it's being pumped to. So are you pumping to a septic tank? Are you pumping to a gravity system? Or are you pumping to some sort of pressurized system that your pump needs to be able to overcome? You need to know what your design flow is. Specifically, what is the flow that your pump needs to be able to handle that is coming into that pump station? If your pump is not capable of handling that incoming flow, you can end up with your system overflowing or a backup occurring. You need to know your static head, so how high you're pumping from your pump to the outfall of your system. You need to know how far you're pumping, or the horizontal run of your pipe. You'll need to know the diameter type of pipe is being used. So are you using 2-inch pipe, 3-inch pipe, 4-inch pipe, Schedule 40, Schedule 80, maybe some sort of stainless steel pipe. You need to know the number and type of fittings that's going to be installed as well. So that's going to be your check valves, gate valves, your elbows, T's, and really anything else that water is going to be moving through from your pump to your outfall. And then lastly, you need to know what your invert elevation is. This doesn't necessarily go into pump sizing, but this will help you in determining how deep your enclosure is going to be in order to have enough storage for that pump to operate correctly. So now let's talk about design flow differences. How do you know what flow you need for an application? So for sewage applications, you can use either the fixture unit method or population method for new systems. And then for existing systems, you can use existing water usage, or how much water is being used by that specific building throughout the year, to determine a flow rate that's required. I'm not going to go too in depth into these. The fixture unit method, though, is going to take into account various fixtures that are going to be supplying water to your pump station. So toilets, sinks, things of that nature. While the population method is going to consider the number of individuals that may be in a building at any given time based on a certain gallon per day value per individual. Whereas, again, that existing water usage method, you just need some sort of prior information in order to size off that properly. Effluent applications is typically going to be driven by your dispersal method. So if you're using a distribution box, typically there's a maximum flow that you can push through that distribution box. So you want to make sure that you're sizing a pump that is going to put out less flow than what that D-box can handle. Pressurized manifolds, low pressure pipe, and drip systems, you typically need some sort of minimum flow in order to distribute that water correctly through that system. And typically the manufacturer of these systems can tell you what exactly you need to meet for proper distribution and use of these dispersal methods. And then lastly, we have groundwater and stormwater systems. Typically, you're going to use the square footage of the basement along with the soil type for sump applications or groundwater applications. This is important to consider because, or specifically, it's important to consider your soil type because water moves much faster through some soil types than others. For example, water moves much faster through sandy soil than it does through clay soil, which means that you're going to have more water collecting in that sump pit at any given time. So you need a pump that is capable of handling those higher flow conditions. Now with stormwater, it's a little bit different. You're going to base this on the square footage of the collection area. So specifically the square footage of the area that is going to be sloped towards your pump station. So any sort of area that is going to be sloped away from your pump station, is not going to really be considered in your stormwater calculation. You also need to consider the rain intensity. So typically you're going to size stormwater systems around a 10-year storm or a 100-year storm, or maybe you'll just have a number of inches per hour that you need to size around. This is typically going to be given to you by local codes and regulations, since it is specific to the installation location. So now let's talk about simplex versus duplex systems. So simplex is, like I've said before, this is just going to be one pump. Usually you're going to use a simplex system in a smaller residential or light commercial applications where it really doesn't make sense for you to have two pumps. Maybe the gallon per day is very, very low, and all you really need is that one pump in operation. And usually you're going to have these be in automatic or non-automatic. If it's non-automatic, I would typically recommend a rail system for an outdoor installation. Then you have duplex systems. So duplex systems is going to be made up of two pumps. And the whole idea behind a duplex station is that you have that extra pump to share the load with your other pump. So typically you're going to have these pumps alternate anytime the system is called to run, so you're sharing the load there. And then also if one pump does end up failing, you have that second pump to keep that system in operation while you get that first pump serviced. Now when it comes to duplex systems, I'm typically going to always recommend using a rail system if it's non-automatic, whereas if it's an automatic system like in a smaller residential system, you can typically get away with two automatic pumps with a residential alternator. But how do you choose between a simplex and duplex arrangement? The main question that I always ask is what happens if that pump station goes down? So for example, let's say you're sizing a system for a restaurant. If you put in a simplex station, what happens if that pump goes down? So basically, the restaurant will no longer be able to use water, since the only pump that is going to be moving water out of that wastewater pit is no longer in operation. You don't want to keep contributing water to that system, so they can no longer wash dishes. They can no longer use sinks or flush toilets or anything like that. Really, that restaurant is no longer in operation. Whereas if you installed a duplex station and one pump went down, you still have that second pump in operation to keep that system up and running. So that restaurant can continue to operate while whoever is going to maintenance that system can get out there, pull that failed pump, either repair it or replace it. So with a duplex arrangement, you're much more likely to be able to keep your systems operating, whereas with a simplex station, you're typically not going to be able to utilize your water system until that pump is fixed. So let's talk about duplex float configuration. So the standard configuration is going to be a 4-float configuration. And that's going to be, you're going to have an off float, a lead float, a lag float, and an alarm float. That off float is really to prime the pump as well as to turn that pump off when the water level drops after that pump completes its cycle. That lead float is going to what's turning on the primary pump. The lag float is there to turn on your secondary pump if that first pump did not operate or if that first pump cannot keep up with the incoming flows. And then lastly, your alarm float is exactly how it sounds. It sends an alarm to the control panel if the water level reaches where that float is located. Now, there is one problem with this sort of arrangement, and that is how will you know if one pump has failed? So this was the standard arrangement for a long time, but what ended up happening was we would get calls talking about how both their pumps failed at the same time, when in actuality what ended up happening was one pump failed, so that lag float kept coming up and calling that second pump to run, and that second pump would pump down that system. The problem is that alarm float was never called, therefore nobody knew that a failure had occurred. So the way to fix that is to swap that lag and alarm float if you want to keep using a 4-float arrangement. So that way, the alarm float will go up first, send an alarm to the control panel, and then that lag float will come on and turn that second pump on. But we figured, why don't we just get rid of one of these mechanical devices and go down to 3 floats instead? So the way we did this is by putting a jumper wire in the control panel. So that way this third float, when it comes up, it will both send an alarm to the control panel and turn on your second pump, thus allowing the maintenance personnel, homeowners, or whoever owns the system to know that they have a pump failure and they need to get that pump serviced. So now let's talk about some pump installation considerations. So first off, you're going to typically always want to use a check valve with your pump station. That is to protect the pump from any water that may want to come back down into your pit after that pump turns off. That check valve is going to close off that water from coming back in above the check valve. It's going to typically have some sort of swing plate that will close shut and thus keep that water in that pipeline. If you don't have that, the water is going to all come back into your sump pit and will thus cause your pump to do more work than necessary. So a check valve is going to be always recommended. Weep holes. So one problem that can occur with a pump station is airlock, and that just means air has started to build up inside of that pump, and eventually that impeller is just going to run in air. It's no longer going to move any water. The way to fix that is through weep holes. So we include a weep hole in our pumps on the side of the pump, but that is one of the first things to get clogged with gritty material. So we always recommend drilling a 3/16 inch weep hole below the check valve and sump cover to allow air to escape and thus keep that pump from being airlocked. Correct float placement is also very important, specifically for non-automatic pumps. You want to make sure that your floats are going to be placed in such a way to keep that pump submerged. Usually with submersible pumps, we're always going to recommend keeping your pump submerged. So you want to put that off float above that pump. Submerged pumps run cooler and thus last longer. And you also want to make sure that you have enough storage capacity between your on float and your alarm float to give you enough time to get that pump serviced if required. Elevation is also important, and what I mean by elevation is specifically you typically want to have that pump on a pump stand if it's an automatic pump or if it's not on a rail system. With a rail system, you're going to have that pump typically a little bit higher off of the ground than just sitting on the ground. And that space is going to help prevent any sort of gritty material from making its way inside of that pump. This is especially important for smaller effluent and sump pits so that you don't end up clogging that pump with that gritty material. And then lastly, you're going to want some sort of alarm or notification. You can typically get this through some sort of indoor alarm that's going to come with its own separate float switch that you can use with an automatic pump. This will give you an alarm if that automatic pump does not operate correctly or if it fails to really pump down that water. Or you can use control panels that's going to have an alarm function. Now, with both of these types of systems, you can get an online monitoring system. Ours is called Z-Control. This online monitoring system is going to give the capability of sending alarm notifications to contractors or homeowners, basically saying, hey, you have a problem with your pit. You might want to get this serviced. This is especially useful for homes that don't necessarily always have somebody there, such as with vacation homes. So this way, you know, even if you are a far distance away, that there's a problem with your pump and you can get that resolved before your basement ends up flooded. So let's talk water tightness. So water tightness is very important for pump applications. So with basin lids and risers, you want to ensure that they are sealed. You also want to make sure that the ground is sloped away from the lids. This way you don't have any water pooling on top of that lid, which can eventually allow water into your pump station. Leaky containers will eventually lead to overwork of the pump because you're allowing more water in than what that pump is really designed for. This can also allow in dirt and grit that can actually tear up the pump and cause a premature failure. So again, make sure your basin lids and risers are sealed and not allowing water in. Junction boxes are notorious for causing failures, and I'm always going to recommend avoiding them at all costs. And that's simply because a direct connection between your pump and your control panel or the incoming power is much better compared to that of a splice connection. Simply because with junction boxes, they can very easily allow water in to the junction box, which can very easily wick into your pump cap or into the control panel and cause a premature failure. Now, if you must use a junction box, we're always going to recommend utilizing a NEMA 4X junction box. Make sure that junction box is fully sealed upon installation. And then lastly, you want to keep that junction box outside of the wet well. This way, you're reducing the chance of condensation and water getting into that junction box and causing a failure. So this is all to say you want to keep water in where you want it and out of where you don't. All right, so the last subject that we're going to talk about today is going to be short cycling. So when it comes to pumps first starting up from rest, they are typically going to be subjected to harsh forces and high current loads compared to the operation forces and loads afterward. So starting a pump too frequently will actually increase the wear and operating temperatures on your pump, which can lead to a premature failure of that pump. So the way to prevent that from happening is to ensure that you are staying below the maximum recommended starts per hour for that pump. Now on your screen, I have some recommendations for different horsepower ranges. For 1.5 horsepower and less, I would typically stick to a maximum of 12 starts per hour. However, we typically recommend 6 to 10 starts per hour for these smaller pumps. Now, when you get to 2 horsepower to 7.5 horsepower, this tends to get a bit larger, and these pumps tend to draw much higher amps. So we would recommend a maximum of about 7 starts per hour. And then when you get to 10 horsepower and greater, 5 starts per hour max is really what we are going to recommend for that system. Now, how exactly do you ensure that you are staying below these maximum starts per hour? The way that you can do that is increasing the pump runtime. So if you have an application where your pump is starting on and off too many times per hour, you can increase the pump runtime. So the way to do that for automatic pump systems is you can use what's called a long cycle kit. And this will increase the amount of time or the amount of storage inside of that pit before that pump is called to run, thus increasing the off time as well as reducing the number of starts per hour. And then for automatic systems, the main way that you can increase runtime is by increasing your float distance between your off float and your on float, thus reducing the number of starts per hour. So this concludes the presentation portion of our webinar. We've uploaded some handouts regarding the information presented here today. They include that grinder pump video that I had shown earlier in the presentation that you can download, along with a few other handouts that can assist you with pump selection and understanding of where exactly different pumps should be used. Please be sure to check those out and download a copy for yourself before you leave today. I hope you found the information valuable, and we'd love to hear your feedback if you don't mind answering a short survey after you sign off. The input we receive helps us develop future content and topics for new webinars, so we really appreciate you giving us your thoughts. And if you enjoy our webinars, we want to be sure you know we also offer in-person training and live virtual training sessions at our Zoller University on-campus location, the Center for Excellence. The center is a 6,000 square foot facility with a classroom area for lectures and a demo room for hands-on learning. Our CFE staff can tailor courses for anyone, whether you're a beginner or a more seasoned professional. And if you can't come to us, we can always come to you with our Zoller University on-the-road product trailer. The trailer is stocked with our latest products, demos, swag, and more. You can reach out to your local Zoller representative to schedule a visit from the Zoller product trailer for your next counter day or event, or book a trip to the CFE. Lastly, we want to talk about Zoller University Online, our online interaction course catalog. Our online courses can be taken at your pace on your own time from anywhere in the world. All you have to do is navigate to www.zolleruniversity.com and create your free profile to start learning. We have courses on products, technical knowledge, promos, policies, and more. Should you think you might have lingering questions, again, please send them our way through our webinars email, webinars@zoller.com. And with that, we'll wrap things up. Thank you all so much for taking the time to join us today. Have a great rest of your day.